Hello Chem 1A, this is Chapter 11, Lecture Video 3, and we're going to talk about our last type of electron group geometry and the molecular geometries that accompany it in this lecture video, as well as do some practice. So in our last example, when we have 6 electron groups, we have what is known as an octahedral electron group geometry. So there are 3 molecular geometries that accompany this: octahedral, square pyramidal, and square planar. Now, if we look at SF6, the Lewis structure of SF6 looks like this. Okay, so here's that Lewis structure, and if we count how many groups are around the central atom, we have 1, 2, 3, 4, 5, 6. And as with all our geometries, when you have no lone pairs on the central atom, this means our molecular geometry is going to be the same as our electron group geometry, in other words, octahedral. Now, this again occurs where all 6 groups, sorry guys, are bonding groups. Right, so the bond angles here there are 2 of them. There's a 90-degree bond angle between a lot of these, actually. So like all of these are 90-degree bond angles. So many 90-degree bond angles all around this thing. There is another couple of 180-degree, right? From here to there, or from here to here is 180 degrees, or from here to here is 180 degrees. So it's a very interesting structure. It has only 2 bond angles, and there are a lot of them throughout. So our bond angles, again, are going to be 90 degrees and 180 degrees. Now, if we look at another example, let's say BRF5, if we draw that Lewis structure, it looks pretty similar to the octahedral, except we're missing one of our bonds, and the one bond that we're missing is now a lone pair. This occurs, when this occurs, we have a total of 6 groups still, right? 1, 2, 3, 4, 5, 6 groups, but one of them is a lone pair, so our molecular geometry changes now. This is square pyramidal. And this occurs when you have 1 lone pair and 5 bonding groups. The bond angles are pretty much the same for all of these guys in this electron group geometry. It's going to be 90 and 180 degrees here as well. Okay, so let's do our last type of molecular geometry, which is square planar. So if we have XeF4, for instance, it looks something like this. And we still have 6 groups total, right? So here we have, our 1, 2, 3, 4, 5, 6 groups. 2 of them are lone pairs, and when that occurs, our molecular group geometry is square planar. So 2 lone pairs and 4 bonding groups. Now, this, again, bond angle wise, is still going to be 180 and 90 degrees. Right? So that's it. That's all of the different geometries. Let's do some practice problems. So first thing, as always, when we're doing practice problems involving VSEPR, is we have to draw the Lewis structure so that we can determine the electron group geometry and the molecular geometry. Now, the first step then would be drawing our Lewis structures, right? Which hopefully we've gotten quite a bit of practice on now. So if we look at BeF2, we first need to draw our skeletal structure, something like this. And actually we've run out of electrons at this point. Now, fluorine can't make multiple bonds. And beryllium's actually one of our exceptions to our octet rule, right? It's actually good with 4 electrons around it, and it has 4 electrons. This is the correct Lewis structure. Now, if we look at our electron group geometry, there are 2 groups around this thing, so it's linear, which means our molecular geometry is also linear, because that's the only molecular geometry for an electron group geometry of linear. Now, if we look at ClF4+, its Lewis structure is going to have Cl in the middle. And so when we draw this out, we can count up how many electrons we have, right? So 5 times 7 is 35, minus 1 would be 34. So I've used up 8. If we keep going here, I have now used an additional 24 electrons. So 24 plus 8 is 32. I have 1 lone pair here on the central atom. This means I didn't really draw the shape of the structure very well. So I'm going to redraw this a little bit to actually imitate what the shape of the real structure will be. Okay, so this is a better representation of the actual shape of the structure. And so still, though, we have 1, 2, 3, 4, 5 groups around the central atom. This means my electron group geometry is trigonal bipyramidal. How do I know that? I have that memorized. Our molecular geometry then would be, okay, great, it's 5 groups, but one of them's a lone pair. That means we got a seesaw as our molecular geometry. All right, so if we look at our next Lewis structure, let's draw that out. Okay, so this will be the Lewis structure of that. And so our electron group geometry is going to be 1, 2, 3, 4, 5, 6. This is octahedral. Our molecular geometry, because we have 1 lone pair and 5 bonds, is square pyramidal. Okay, we got one last structure to do. And so if we draw that guy out, which is PBr5, I'm going to do it up here. And it looks something like this. There are 5 groups around that electron or that molecule. 1, 2, 3, 4, 5. So our electron group geometry is again trigonal bipyramidal. And our molecular geometry, since we have no lone pairs, is also going to be trigonal bipyramidal. Now, one of the things I could have also asked would have been, like, what are the bond angles present? So you should be able to determine that for all of these as well. Okay, if you have any questions at all, as always, please don't hesitate to contact me. I'm always happy to help.